All right, so amides are when you have the carbonyl group attached to a nitrogen, right? That's what makes it an amide. And similar to amines, we can classify amides based on the number of carbons attached to the nitrogen. So you can have a primary amide, like what is shown down here, right, where you have one carbon-nitrogen bond. You can also have a secondary amide where you have kind of the carbon-nitrogen bond from the carbonyl to the nitrogen, but then another one, which would be to like a methyl group or an ethyl group or something like that. So that would be a secondary amide. And then your tertiary amide would have your carbonyl carbon attached to the nitrogen, and then you would have two extra substituents, right? And again, these substituents are going to be like methyls or ethyls or propyls or something like that, only carbon containing substituents. So in all of these, we're only looking at one of the carbonyl carbons, which is what makes it an amide in the first place. In terms of naming an amide, so basically we're going to name amides very similar to how we name carboxylic acids. So kind of what you have to imagine is that if you were to name this one over here on the left, right, you would say, okay, I'm looking at that structure there, and I could imagine if it was CH3, C double bonded to O, bonded to an OH, you could imagine that would be acetic acid. But what's happening here is instead of that OH being there, right, the OH isn't there, and we take that away, and instead here we're going to have the NH2 that's there, right? So we're still going to say it's derived from acetic acid. So it's like the parent chain is based on that carboxylic acid. And with that parent chain coming from the acetic acid, all we're going to do then is change the suffix to say amide. So instead of acetic acid, we're going to say acetamide, right? So that would be that one. Same thing over here. The parent chain would be this. You imagine that would be benzoic acid. However, in this case, it's not a carboxylic acid, so we have to change the suffix. We drop the oic acid, and it's going to be benzamide. Now, we would use acetamide or benzamide or whichever other amide is kind of like the parent chain. And then if there were other substituents attached to the nitrogen, then we would name them as substituents, which is shown here, similar to what we did with the aniline, where we used the prefix of N. So the parent chain, and it says here the RCO group. In other words, that's going to be the carbonyl, that's the C double bonded to O bonded to N, right? So if we had, that's our amide functional group, right? So now let's say we had CH2 and we had CH3, and then attached to this N we had a CH3 there and we had a CH3 over there. Well, in this case, the structure would be the parent chain would have this part, right? So that's going to be our parent chain. It's a 3 carbon long parent chain, so that would be like propane. If it was a carboxylic acid, we would call it propanoic acid, right? So, but it's not propanoic acid, it's going to be propane. Instead of oic acid, now it's going to be amide in terms of the suffix, right? So propanamide covers the part that is circled there as our parent chain. But now we have two substituents we have to deal with. We have a CH3 there and a CH3 there. So those are both methyl groups. So in terms of writing the name and number of those substituents, right, we don't really give them a number because they're attached to the N. And each one needs their own number. Just like sometimes whenever we were numbering things, we could have numbers like, 3,3-dimethyl, hexane or something like that. Well, in this case, we're going to have that same letter twice. It's going to be N, dimethylpropanamide, which basically tells us that there are two methyl groups, dimethyl, right? These two methyls. Where are they both attached? Well, one of them is attached to an N and the other one's attached to an N. So NN-dimethylpropanamide would be how you name that structure that I just drew up there. All right, so here are a couple others to practice. So the first one, again, let's find the parent chain to start with. So in finding the parent chain, we're going to take the part that's the amide, which is right there, and then we're going to take all of the carbons directly attached to the carbonyl carbon. So again, this right here in the middle is going to be the carbonyl carbon, and we're going to find the carbons that are directly attached to that. So we can't go through the end, we have to go through where all the other carbons are. So we're going to continue this that way. And now we need to count how many carbons are there. Well, there are 1, 2, 3, 4, and then 5. Don't forget to count the actual carbonyl carbon, that's C double bond O. So in this case, there's 5 of them. So that's going to be like pentane, but in this case, it's not going to be just pentane. It's pentanamide. All right, and now we still have to account for our substituents, right? We don't have to name the hydrogen, but we do have to name this CH2CH3 group, which is called an ethyl group. We have to name and number it. Well, what is it attached to? Well, it's not attached to any of those carbons that have a number. Instead, it's attached to the nitrogen. So that's going to be N-ethylpentanamide would be how you name that top structure. All right, so now on the bottom one, let's try to draw it based on what it says. So NN-dimethylbenzamide. So again, working backwards, we're going to start with the benzamide. Benzamide, you have to recognize as one of those common ones you needed to know, which would be when you have an amide attached to a benzene ring. Whoops, not an N there yet. First, we need our C. All right, we need to make this. So this would be, right there would be benzamide without the NN-dimethyl part. That's just plain old benzamide, right? So now to make it NN-dimethyl, we have to go in and attach our methyl groups. So we're going to remove those hydrogens because that's where they attach to the N. And now we're going to draw a methyl there and a methyl there. And that would give us NN-dimethylbenzamide.